Welcome to the final exam, question number 25. It says, select the correct statements about the three-span continuous beam shown above, neglecting the weight of the beam. Alright, and we have 1, 2, 3, 4, 5, and 6. Lots of options. 1, 2, 3, 4, 5, and 6. Alright, let's go down the list, see what we got. The moment at B is negative. I'm sorry. A, B, C. And to tell you the truth, this isn't 100% the easiest question ever. It's actually rather difficult in my mind because right off the bat, I don't think that's 100% obvious. I mean, I guess you could say, obviously it's not going to be positive because it's not going to have a smiley face at that point. So it should be negative. Well, I guess I don't want to say will not, but I don't see it happening. It should probably be negative, or it should be a 0. Which I would say the first thing you should do is go ahead and throw on a assumed three-body diagram. And if you think about it, you do free body diagram, this is Vx, and let's do a moment diagram as well. FBD, free body diagram. Alright, so we are making some assumptions here. What would the free body diagram look like? Well, let me change colors here. This, I think it's obvious, is going to be going like so. And we know that's happening. Now, if this was free to do nothing, and obviously the beam is weightless, then it would come up like that. And this would not have any bend to it. It would come off at whatever angle the load induced. The load's going to make a moment, and that moment's going to make an angle, and you'll see it's all related. If you want to get any further into structural engineering, you could figure out this angle as long as you know what the load is and what what your beam properties are. So, but that's not the case. We're actually holding that down, so the beam's going to kind of deflect like so. And actually, it's going to be more right here, and then it's going to kind of level out like so. So that's what the beam is going to look like. What will it do? Since if we let go of this, it would pop up like so. We have to say, okay, well, since we do have a reaction there, it's like pushing it down. So we know we're going to have an uplift situation here. The reaction here is going to be down. I'll put it down here. But you can think about taking your finger and pushing that beam back down. The reaction is going to be right there. And we know this reaction is going to be going up. And we know, well, we're going to assume that this reaction is going to go up. And then we're going to have this equivalent load right here. Alright, which you would be correct in assuming that. So when we take a look at this, we take a look at the free body diagram. We're going to see something that looks like this. And then it's going to be up. We're going to have oh gosh, that distributed load got it way out of control. You're going to have a distributed load, and you're going to have another reaction. So that's generally, obviously it would be easier if you put numbers on here, and I don't believe that this is easily, I think it's a indeterminate beam, so it doesn't really matter. You can try to figure it out, but it's not going to work. Alright, don't hold me to that, I might be wrong. But anyways, we're not doing that, we're just assuming, hey, here we go, we don't have any numbers, so we just got to work with what we got. So the Vx is going to look like this. It's going to go down a little bit, and we're assuming. And then nothing is happening to it. Then I'm assuming we're going to go up more. That makes sense. and then we're going to slowly come down. Something like that. Obviously, imperfect. It's probably more like, let's just say it looks like that. There we go. So our moment, this is going to be a constant line, a constant slope, I'll say. And then it's going to and I kind of messed this up, but hopefully this makes sense. Since I made this positive, this will be negative. So it'll be going more negative at first until it gets to the point right there. Well, sorry. Let me think, what would it look like? Yeah, I think the beam actually looks something like this. And then it would go positive. So I was probably more correct the first time when I had it a little bit higher and coming over like that. But anyways, that's not the point. The point is, this is what it looks like. So at this point, there's a negative moment. So, all right, let's go back to the stuff. We said the moment at B is negative, and I think no matter what, sorry, I know why I messed up on this. We'll do it opposite, not opposite. Okay, here we go. This goes up, and let's say this comes down like so. All right, and then negative moment. And we'll say since it's south of the line, it's going to be negative. Then it's going to go. It's going to increase more until it gets to 0 at that point, and then it's going to go down. That's generally what it's going to look like. So when it asks for number 1, it says the moment at B is negative. And here's B. And yes, it is negative. So I would say yes. Sorry, that took so long to get there. All right, the reaction at A is downward. And I would say that is also correct because the reaction is going... It's an uplift. And I assuming that's what they're trying to get at. The reaction at A is downward. Sure. Then we go on, the moment in span AB is always negative. The moment, I would say yes. This is always negative. So I say yes. Number 4, the moment in span AB changes from positive to negative. The moment in span AB, remember this is A, B, changes from positive to negative. No, it's negative all the time. So that's incorrect. No. All right. Go on to 5. The moment in span BC is always negative. The moment span BC is always negative. No, it's negative. Let's change colors. Looks like it's negative. Let's go to a more red. See if we can find something. Yeah, that'll do. Right here it's negative. But over here, in, let me think, green, let's do it. This is positive. Let's put positive. And over here it's negative. All right, so that's incorrect as well. So no. And then number 6, the moment in span BC changes from positive to negative. Well, I would say negative to positive if you're going left, right, but positive to negative, sure, it changes, depends which way you're looking at it. So that'd be a yes. So let's see here. We had 1, 2, that's 3. 1, 2, 3, and 6. Do we have an answer? That's 1, 2, 3, and 6. 1, 2, 3, and 6. A is actually 1, 2, 3, and 6. And that's one we want. So let's call it A and call it good. I hope this made sense to you. Since there's so many questions about that, I would have gone ahead and thrown a free body diagram, a shear diagram, and a moment diagram on there because since it is indeterminate, knowing exactly what that is going to be about impossible. But that looks about right. And we know that's always going to be... Let me think. Is there any chance that it could be... I'm trying to think here. Is there any chance that it could be where it goes down and then it only goes up to there. Is there any possible way? No, it could not do that, because then it always has to have positive moment. Because if it didn't, that would mean this reaction is 0. And this is not 0, it's positive. Alright, sorry, I was just thinking out loud there to see if there's any point where this moment diagram would have not gone into the positive region and B, C, but it always would. So, alright, hope I didn't confuse you with that last little part. If not, just go back and rewind and stop right when I start ranting. Alright, correct answer is A. I will see you in the next video.